Hello everyone. Hello everyone. Welcome to KT Semicon Self-Based Learning Module. In this particular session, we are going to see how to develop a test bench and we are going to verify our design is working correctly or not. So let me first of all share my screen. So we have developed our simple APB master. Now it's time to develop a test bench or it is acting as a slave. So I'm going to write down APB underscore slave or it is also a test bench. Okay. For our APB master. So let me finish creating this particular file. Now, first of all, let me declare the signals which are needed. So let me declare the signals as clock and reset and for this particular slave or the test bench is going to drive the signals like p select, that's why it is I've declared them as wire, p enable. So sorry, this particular master is going to provide the signals to my slave or the test bench. From the master we are going to get those particular signals, you can see over here. So the P select signal, P enable signal, P address signal, PW data signal, P write signal, P not P ready, up to P write. The master is going to give these signals to our test bench or you can say slave. Okay. So that's why I'm going to declare these signals as wire. Okay. So let me declare them as wire. So wire P select, wire P enable, next wire 31 down to 0 P address, next wire 31 down to 0 PW data and wire P write, and our slave or the test bench is going to give the master P ready signal. That's why I'm going to declare it as rich. Okay. Next, the slave or the test bench is going to drive these signals like W data address transfer, right? So that's why I'm declaring them as rich. Okay. So rich, we have transfer and rich 31 down to 0 address and rich 31 down to 0 W data and rich write. Okay, after declaring these signals we are going to instantiate my master in a slave. How to instantiate APB underscore master dot. So I'm going to follow connection by order, reset underscore n, transfer address W data, write p select, p enable, p address, p w data, p write and p ready. So these are the signals which my master is going to have. Basically I'm following connection by order. So whatever the signals which we have declared in order, that particular signals I have declared. Okay, lastly p write, p ready. Next what I'm going to do is I'm going to first of all generate my clock. How to generate my clock? Within an initial beginning block, I'm going to initialize my clock first. Next I'm going to end this and within an always block, always hash 5, clock is equal to not of clock. I've generated my clock. Next I'm going to initialize my variables. So let me initialize over here only. Clock within a concatenation operator, clock comma transfer reset underscore n and w data. Let me write down write p ready. So these signals will be equal to 0, made to equal to 0, and also w data signal will also be made to 0. Okay. So I made all my input signals which I'm going to provide to master to 0. Okay. Next, so within an initial beginning block, after some time, let's say after 20 time units, I'm going to remove my reset signal. I'm going to make it to 1. Okay. Next, so next at passage of clock, what I'm going to do is I need to write down within an initial beginning block. Yeah. So at passage of clock, what I'm going to do is I'm going to make my transfer is equal to 1. Next, I'm also going to provide the address. Address is 32 tick H A B C D underscore 1234. This is the address which I'm going to give. And also data, I'm going to give it as some face underscore give. So this is the data which I'm going to provide, and it's a write operation. So I'm going to tell the master to perform a write operation. Okay. And after at another passage of clock, I'm going to make this passage of clock. I'm going to make this transfer to 0. That means to stop the transfer. This is only transfer we are going to have. Okay. Next, after 3 cycles, what I'm going to do is, so for 3 cycles, what I'm going to do is, I'm going to make my P ready to 1. For 3 cycles, my P ready will be equal to 1. So for 3 positive cycles, my P ready will be equal to 1. And at the next cycle, my P ready will be equal to 0. Okay. So this is what I've done. Okay. And followed by end module. Simple. So from our slave, what are we going to do simply is add followed by end and end module. So for from our slave, what are we going to do is we are going to provide the transfer signal, data signal, address signal, and write signal. That means we are basically trying to tell the master to perform this particular operations, and we need to check for our PW data signal, P address signal. Those particular signals we need to verify. Okay, that we are going to verify in our next session. So that's about how to develop a simple APB slave and a test bench. In the next session, we are going to see how to verify your master. So that's all about this particular session. Thank you.